All right, good afternoon. All right, let's finish up this study guide. Okay, so first thing is that you are told that triangle ABC, which is the big one, is a right triangle, which means that it has a right angle down here at A. Okay, and it tells us that EG is a midsegment. So the reason it tells us that is because it wants us to remember that EG and AC are going to be parallel. So we need to think about corresponding angles, and we need to think about linear pairs, okay? So here's a quick reminder about our corresponding angles, okay? So our corresponding angles are gonna be one inside the parallel lines, one outside the parallel lines, and on the same side of the line, okay? So this is what corresponding angles look like, and remember that corresponding angles are always congruent, okay? So they're gonna be the same size. So if I look at A, angle A is 90, which means that the angle on top of the other parallel line at E is also going to be parallel. Sorry, I don't know why it's getting so blurry on you. All right, so this one is also 90, okay? They tell us that angle 1 is 50, so I can go ahead and put 50 degrees right here for angle 1. And again, this time, instead of going up to the next parallel line, I'm gonna come down, stay on that same side, come down, and right here on this corner, because of corresponding angles, angle C and angle BGE are the same size. So this angle is also 50. All right, so we've done all of our corresponding angles based off of the information provided. The next step is to look for linear pairs. Okay, so remember, a linear pair are two angles, okay, that are adjacent, which means they're right next door to each other, and they form a straight line. So remember, linear pairs are supplementary, which means they equal 180, okay? So right here at G, I know that these two angles, so let me use a different color. All right, these two angles right here, okay? So I have 50 on the top. I need to figure out what would go down here so that these two angles together equal 180. So I'm really doing 180 minus 50 to get 130. So this angle down here is 130. All right, so I'm gonna come across to the other side. I'm gonna do the exact same thing. Okay, this one's a little bit easier because it's a 90, but I need to recognize that there's a pair of linear angles right here as well. So remember, this box means 90. Take away 90, I get another 90. You can write the number, or you can go ahead and just put another box there. All right, last but not least, we have our vertex angle up here at B. So what I did for this one was I looked at the triangle, the little one here at the top. Okay, this little triangle right here. All right, so this triangle, okay, I want to find an angle. Well, I know that all the angles in the triangle, okay, so all my angles in my triangle equal 180 in every triangle, remember? All right, so one of them is 90, one of them is 50. So I want to add that together, okay, so 90 plus 50, sorry, this is getting a little cramped. This is 140. So then I'm gonna take my 180, because I know that all three together are 180, and subtract what I have, which is 140. And what's left is 40. So that means angle B up here is 40 degrees, okay? We didn't really use same side interior angles, and you don't really have to, okay? So you can see down here at the bottom that we have some notes here, but if you are good at recognizing same side interior angles, remember, these are supplementary. If you're not good at it, that's okay. You can just use the linear pair, okay? So supplementary, which means they equal 180. And then our corresponding angles are always congruent or equal to each other, okay? All right, so this one was angles in mid-segments. So this is that delta math that you guys did. Okay, last question is all about slope, okay? You will be provided with the slope formula. So if you come down to the bottom here, I'm gonna give this to you, okay? But you need to know how to use it, and then you need to know how to compare your numbers, okay? So slope formula, we use the letter M for slope. It is the change in my y value, so y2 minus y1 over x2 minus x1. And these are our two ordered pairs that they give you. So I put a graph here for you, just in case it was easier for you to kind of visualize so you can see what we were doing. So we have 4 questions because we're asked to find the slope of all 4 lines up here. They give us the ordered pairs. So remember, step number 1, when working with my ordered pairs, is that I want to stack my ordered pairs. So this helps me keep my numbers together. So first I do A and B, so that's 1, 3, 5, 1. All right, when I do my slope, it's essential that I do my y values first. Okay, I have to do those in my numerator. I'm gonna do my bottom minus my top. 1 minus 3. And then for my x's on the bottom, 5 minus 1. Use your calculator if you need to. This is gonna give you -2 over 4. All right, you always want to simplify your fraction. Okay, so you wanna simplify your fraction. Now, I'll show you how to do that on the calculator. So if you have my calculator, okay, it will do all that for you. So we have a -2 over 4. I hit enter, and it gives me a decimal. So what you do is you hit this button, the little squigglies, right above the equal sign. Here, I'm gonna zoom out for a second. If I hit that button, watch the screen, it turns it into a reduced fraction, which is what you want for every single slope that you do, okay? So instead of leaving this as -2 over 4, I want to go ahead and simplify that to that -1/2 that my calculator told me. Okay. All right, so right now we're just gonna do them all, and then we'll compare and talk about what parallel slopes look like and what perpendicular slopes look like. Okay, so for B and C, B is 5, 1, C is 8, 7. Again, I need to do my y's first. 7 minus 1, 8 minus 5. This is 6 over 3. Again, type it into your calculator. This gives you a 2. All right, DC. D is 4, 9. C is 8, 7. Do my y's first. 7 minus 9 over 8 minus 4. This is going to give me a -2 on the top, +4 on the bottom, which is the same thing as letter A gave me. So I know that that's going to reduce to a -1/2. All right, last but not least, AD. So A is 1, 3. D is 4, 9. Do your y's. 9 minus 3, 4 minus 1, 6 over 3, 2. All right, so I've got all my slopes. All right, they want me to check AB, which is my first one. Here's AB. And they want me to check DC. So DC is this one. So I'm comparing these two numbers, -1/2 and -1/2. So I have 3 options. I can call them parallel, perpendicular, or neither. So let's come over here, and then I'll come back to this one. So parallel slopes are the same sign. Oh my gosh. Same sign, same number. So they're identical. They're exactly the same, okay? So this would be like the number 4 and the number 4. Like 7/4 and 7/4. -2 ninths, -2 ninths. I don't know, 5 and 5, okay? They have to be absolutely identical. Same exact number, same exact sign. Okay, perpendicular, they are opposite signs. Okay, meaning one is positive and one is negative. And they are reciprocal numbers or flipped numbers. Okay, so some examples. Now I'll put some special cases down at the bottom. All right, some examples would be like, let's do this first one. So like 4 and -1/4. Okay, we talked about it the other day that when you have a whole number, every whole number has an invisible denominator of 1, which is where this 1 comes from when I flip that fraction. That's called the reciprocal. When you put what's in the numerator at the denominator and what's in the denominator at the numerator. All right, here's another one. So again, I'm going to use this one. Okay, let's say this is, I'm going to change it to a negative 7/4 to start with. Negative 7/4. So I'm going to do the opposite sign. So it's going to be positive, and then I'm going to flip these numbers, and it's going to be a positive 4/7. All right, my 2/9. So if I started out as a positive 2/9, I'm going to change my sign, negative, and I'm going to flip my number 9/2. Okay, so there's some special cases. I'm going to put them down here. So special cases, okay? We have our 0 and our undefined. And in a fraction, this is going to look like 0 over some number and then some negative number over 0. So like when you do your slope formula, this is what you get for this one. These are always perpendicular, always. Another special case is a positive 1 and a negative 1, okay? Now, while it doesn't look like it's been flipped, reminder that these are 1/1, and then when I flip it, negative 1/1. So again, it doesn't look like it's been flipped, but it absolutely has been for 1 and negative 1. All right, so now if it doesn't meet any of these requirements, then we call it neither. Like this is an and, okay? This is an and. It has to have both the same sign and the same number. And then for perpendicular, it has to have both the opposite signs and a flipped fraction. Okay, so like if it doesn't have both, if it only has one, then you write neither. Okay, so we look at our two numbers. They are both negative, so they are the same sign. And they are both a 1 on the top, a 2 on the bottom. So because they are exactly the same, we call them parallel. Okay, call them parallel. All right, so this is what you'll be tested on. Please make sure it's all the way complete. The key is uploaded in the same posting as this video. Make sure you bring it to class on Monday. Make sure you go back over this, practice it, okay? Look through your notes, and I will see you Monday. Have a great weekend.